is Lena Soler, and I'm a civil engineering undergrad student from the University of Puerto Rico at Mayagüez. This summer, I had the opportunity to work with Professor Gustavo Parra Montesinos here at the University of Michigan on a research titled Bending, Tension, and Compression Test on Steel Fiber Concrete. The objective was to determine the effect of steel fibers on the behavior of concrete in tension, compression, and bending. Fibers provide concrete with post-cracking strength. This means that it will be a more ductile material when subjected to tension and compression. Hence, this project was aimed at evaluating the behavior of concrete when the mixture proportions of conventional materials such as cement, stone, sand, and water remain the same, and the only variant is the volume of steel fibers. 6 batches of 3 different mixes were made, in which the volume of fibers was either 0.5, 0.75, or 1% of the total mixture. The first test that we did were the compression test. From each batch, 2 cylinders having a diameter of 4 inches and a height of 8 inches were tested under compression. In order to measure the cylinder's displacement, sensors were located along the cylinder length over a 270 arc, as we can see in the picture. The results show that even though the compressive strength is not substantially affected by the quantity of fibers in the mixture, the compression ductility increases with an increase in the amount of steel fibers. The second test that we did were the bending test. For each batch, a beam specimen with dimensions of 6 by 6 by 20 inches was cast. The beams were tested under 4-point bending. Since maximum moment occurs at the 6-inch span in the middle of the beam, 6 sensors were located at 6 inches from each support at various heights. Also, 3 sensors were placed at the middle of the beam. As we can see from the results, concrete's post-cracking strength and ductility increases with the amount of steel fibers. The last test that we did were the tension tests, which the results were very similar to the bending test. However, the setup was completely different. We used a mold that was 4 by 4 by 10 inches with 2 halves of a half-inch diameter rebar, as shown in the figure. A notch of 75 inches deep was made in the concrete in order to control the location of the crack. Markers were placed along the width of the opening in order to monitor the crack width as the test progressed. During the test, tension was applied to the steel bars, subjecting the concrete to tension. As I mentioned previously, these results were similar to the ones in the bending test. The post-cracking strength and ductility increased with an amount of steel fibers in the mixture. Finally, results from the compression test indicate that the compressive strength is not substantially affected by the quantity of fibers in the mixture. Compression ductility increases with an increase in the amount of steel fibers. From the bending and tension test, it can be determined that the concrete's post-cracking strength and ductility increases with the amount of steel fibers. Thank you very much for your attention, and I hope that you enjoyed the presentation.